Okay, this video is for problem number 5. We've got a test that contains 10 multiple choice problems. The student knows the answers to 6 of these problems. Now, it should be really clear here. This question could be a little bit more clear. When we say a student knows the answer to 6 of these problems, we mean that this student will miss the other 4 certainly. So the instructor selects 5 of the 10 problems at random for the test, and we want y to be the number of problems that this student answers correctly. So find the theoretical mean and variance of this variable y. Keep in mind, or starting off, we want to identify, is this a binomial situation? And the answer is no, right? Because as the instructor selects one problem, the probability of the student getting that problem, or the probability of that problem being one that the student knows, changes as the instructor selects problems, because the instructor is choosing problems out of a set and not replacing them, right? The instructor is not going to ask the same question multiple times. And so because every time the instructor selects a problem, the set from which the instructor is choosing the problem decreases, the probabilities are changing. So this is not a binomial situation. We don't want to treat it like that. So let's look at the solution. So you can see here in number 5, ignore the top there. So I've got my variable y. I had started out my table with zeros and then realized, oh, that's not possible, because if the instructor is choosing 5 problems and the student knows the answers to 6 of them, well, there are only 4 that the student is going to miss at the most, and so the student has to get at least 1 right, because there are only 4 that student's going to miss. So we're starting our variable with 1, and the most that the student can get correct is 5, because there are only 5 problems being chosen. So even though the student knows 6 answers, there's only a set of 5 problems, so our variable can go from 1 through 5. And I put the squares there as well. Now the probabilities, we want to think about that, right? So this first row is for the ones. It doesn't quite match up here in this first row, so just hopefully you can follow that. But the number of possible configurations of this test are 10 choose 5, right? So we've got 10 choose 5, and that's our denominator throughout. And then in the numerator, so for one correct problem, how many ways can that happen? Well, we've got 6 choose 1, and then we have to choose all 4 of the incorrect, or all the 4 of the problems the student's going to miss, right? So 6 choose 1 times 4 choose 4 over 10 choose 5. And I didn't work those out on a calculator. You can do that on the test. Feel free to leave it in combination notation as well if you do a problem like this. But for 2 correct, we've got 6 choose 2 times 4 choose 3, because we're choosing 2 correct problems and 3 incorrect problems, and then likewise, and etc. down through the rest, right? So for 3 correct, we've got 6 choose 3 correct problems, 4 choose 2 incorrect problems, all the way down, right? In the next column, we're simply multiplying that variable times the probability that it happens, and so I've worked that out. The denominator is 252. You can kind of work through that, and we can find that the mean here is 3, right? 756 divided by 252. Again, we work out the expected value of the square of the variable, right? So the expected value of the square is 29/3. And so if we take the expected value of the square of the variable minus the square of the expected value of the variable, we get 2/3. And that's our variance. And that's all there is to it. Again, ask me if you aren't sure about any of that, but it's pretty simple once you know what you're doing.